हेलो स्टूडेंट्स। तो आज हम ना कंसंट्रेशन सेल्स के बारे में पढ़ेंगे और उनकी ईएमएफ कैलकुलेशन को भी देखेंगे। साथ ही साथ हम अपने जो सेल्स है उनके थर्मोडायनेमिक एस्पेक्ट के बारे में भी स्टडी करेंगे हम। ठीक है, तो जैसे कि गिब्स पे एनर्जी कैलकुलेशन कैसे करते हैं, इनट्रोपी का कैलकुलेशन कैसे करते हैं, ठीक है, ईएमएफ और इनट्रोपी में क्या रिलेशन है, ये सारी चीजें आज हम देखेंगे। चलो सबसे पहले स्टार्ट करते हैं कंसंट्रेशन सेल से। तो अगर मैं कंसंट्रेशन सेल की बात करूं तो हम क्या करते हैं, सबसे पहले कंसंट्रेशन सेल की जो बात करूं अगर, तो उसमें हम जो दोनों इलेक्ट्रोड्स होते हैं ना, वो दोनों के दोनों सेम होते हैं। ठीक है, वो दोनों इलेक्ट्रोड्स सेम होते हैं, तो ऐसे को हम क्या बोलते हैं, कंसंट्रेशन सेल बोलते हैं। अब हो सकता है कि ये दोनों जो रॉड्स है या फिर इलेक्ट्रोड्स है वो सेम सॉल्यूशन में डिप किए हों या फिर डिफरेंट डिफरेंट सॉल्यूशन में डिप किए हों, पर जो अपना स्पीसीज जो ऑक्सीडाइज या रिड्यूस हो रहा है वो दोनों में कॉमन है। जैसे कि एग्जाम्पल के लिए अगर हमने एक सॉल्यूशन लिया H+ का CH सॉल्यूशन और हमने दोनों जो इलेक्ट्रोड है, प्लेटिनम और हाइड्रोजन वाले इलेक्ट्रोड जो है, स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड है, उन दोनों को एक ही में डिप कर दिया। दोनों में डिफरेंस क्या है कि एक में प्रेशर P1 है और एक में प्रेशर P2 है। ठीक है, तो ऐसे को हम क्या बोलते हैं, इस तरह के को हम बोलते हैं कंसंट्रेशन सेल्स, जिसमें जो ईएमएफ के जो फॉर्मेशन हो रहा है वो कंसंट्रेशन के कारण हो रहा है। मतलब बेसिकली कंसंट्रेशन डिफरेंट है, तो एक तरह से आप समझ सकते हो कि टेंडेंसी जो है एक की ज्यादा, एक की कम ऑक्सीडाइज होने की और एक की ज्यादा रिड्यूस होने की। ठीक है, ऐसे करके है चीजें। तो इसे हम ऐसे डिनोट किया हमने। अब देखो यहाँ पे ये दोनों इसमें इसमें डिप है, कैसे पता चलेगा, क्योंकि बीच में कोई सॉल्ट ब्रिज नहीं लगा, मतलब कोई सेपरेशन नहीं है दोनों के बीच। बीच में अपना इलेक्ट्रोलाइट सॉल्यूशन है और दोनों लेफ्ट राइट क्या है, हमारा इलेक्ट्रोड है। क्लियर है? ओके, एक और एग्जांपल है हमारे पास कंसंट्रेशन सेल का। जैसे कि अगर हमने PbSO4 का सॉल्यूशन ले लिया और एक तरफ लीड अमलगम C1 कंसंट्रेशन पे और दूसरी तरफ लीड अमलगम C2 कंसंट्रेशन पे ले लिया और दोनों को एक ही जगह डिप कर दिया, तो ये भी क्या है, कंसंट्रेशन सेल का एग्जांपल है। ओके, दिस इज आल्सो एन एग्जांपल ऑफ कंसंट्रेशन सेल, क्योंकि दोनों जो ऑक्सीडाइज और रिड्यूस हो रही है स्पीसीज, वो दोनों के दोनों सेम है, सिर्फ हमने कंसंट्रेशन को चेंज किया। ठीक है, क्या किया हमने, सिर्फ हमने कंसंट्रेशन को चेंज किया है। जैसे कि यहाँ पे हमने प्रेशर को चेंज किया था, तो हाँ, हो सकता है कि प्रेशर चेंज हो या फिर हो सकता है कि कंसंट्रेशन चेंज हो। दोनों के केस में हम इसे कंसंट्रेशन सेल ही बोलते हैं। क्लियर है चीज? ओके, नेक्स्ट आगे देखते हैं हम। सपोज हम इसी सेल जो अपना सेल रिप्रेजेंटेशन है, इसके लिए सेल रिएक्शन लिखना चाहे तो कैसे लिखेंगे? सेल रिएक्शन कैसे होगा, अगर 2H+ से हमारा देखो लेफ्ट हैंड साइड क्या हो रहा है, H2 जा रहा है H+ में, मतलब जो P1 प्रेशर पे है वो H+ कंसंट्रेशन में जा रहा है, और जो P2 है वो किस में आ रहा है, वो H2 में आ रहा है। तो H1 क्या हो रहा है, एक के लिए अगर हम लिखा कि H+ is taking 2 electron and going to H2 which is at P2, तो राइट हैंड साइड में ये चीज हो रही है। ठीक है, और लेफ्ट हैंड साइड में H2 किस में जा रही है, 2H+ में। तो ये हो गया हमारा ओवरऑल रिएक्शन। अगर हमने दोनों को ऐड कर दिया, क्योंकि हमने दोनों इलेक्ट्रोड सेम कंसंट्रेशन में डिप किया है, H+ का कंसंट्रेशन दोनों में सेम होगा, सिर्फ प्रेशर जिससे हम बबल करवा रहे हैं हाइड्रोजन गैस को वो डिफरेंट है। तो हमें फाइनली क्या मिला, ये इक्वेशन मिला, दैट इज हाइड्रोजन एट प्रेशर 1 इज इन इक्विलिब्रियम विद हाइड्रोजन एट प्रेशर 2। तो दिस इज द कंसंट्रेशन सेल। ओके, अगर अब हम क्या करना चाहें कि इस रिएक्शन के लिए हम नर्स्ट इक्वेशन लिखना चाहें, तो ये जो रिएक्शन है वो क्या है, इंडिपेंडेंट है इलेक्ट्रोलाइटिक कंसंट्रेशन पे ऑफ कोर्स, क्योंकि कंसंट्रेशन क्या है, दोनों के सेम है। तो हम लिख सकते हैं at moderate pressure H2 can be considered as an ideal gas, so the ratio of activity to be equal to the ratio of gas with pressure which is P2 by P1, right? So इससे हमें क्या वैल्यू मिलेगी, E cell is equal to E naught cell minus RT by NF, which is 0.0591, okay, log P2 by P1. This will give you a Nernst equation for the previous reaction for this. Okay, for this one. Okay, this is for this we have this Nernst equation. Clear? Now this is a very, very important formula. It's delta G is equals to minus NFE, where N is the number of electrons involved, F is the Faraday constant, and E is the EMF of the cell. Suppose if the concentration of all the reacting species is unity, then we can write that E cell is equals to E naught cell. Okay, because we are taking standard condition and E naught cell is representing standard condition only. Therefore, we can write delta G naught is equals to minus NFE naught. Where delta G naught is free energy at standard condition. And now further, if you just write it in this form, this is also possible. So what is the derivation of this equation? So we know that dg is equals to vdp minus sdt from Maxwell's equation. Now at constant pressure, we can write the same equation that is written above in this way. Because pressure is 0, so dg is equals to minus sdt. That will give you s is equals to minus dg by dt. Clear? So this is the formula that we have. Now we'll put simply NFA here in place of G. Now we know that N is constant, F is constant, but E should be in the braces. That will give you delta S is equals to NFE dt. Clear? So this is the derivation of it. You can just look at here. So we have just placed the minus NFE in place of delta G, and that will give you this, which is delta E by delta T, which change in EMF with temperature at constant pressure is equals to change in entropy per unit per unit electron. Clear? Okay. Now we know that delta G is equals to minus NFE. At equilibrium, delta G is equals to 0. Okay. So what are we saying here? That we know the formula that delta G is equals to minus NFE. And at equilibrium, delta G is equals to 0. Okay. So that will give E cell is equals to 0. So we can say that equilibrium, the EMF of any cell is 0. And Q is equals to K. Therefore, we can write E cell is equals to E naught cell minus RT by NF ln K. From last equation we have written this. Because here E cell is 0, Q is equals to K, therefore E naught cell is equals to RT by NF ln K. So this is the overall formula. Okay, this is the overall formula. So these formulas are very important because these are the thermodynamic aspect of the reaction. Now let us solve a question. The question says that you have to calculate the EMF delta G naught for the cell reaction as 25 degrees Celsius. Okay. And this is the cell equation that we have. And E naught for Zn 2 plus 2 Zn is given. Means reduction potential of zinc 2 plus ion is given and reduction potential of cadmium 2 plus is given. So these two things are given. We have to calculate the EMF. How we calculate it? Okay. So we know a very simple formula. Delta G naught is equals to minus NFE. Okay. Delta G naught is equals to minus NFE. So we need E naught also. So what is the species that is getting oxidized? So Zn to Zn2 plus means Zn is getting oxidized. Of course, it is written on the left side. So do you know the oxidation potential of Zn2 plus? No, we know the reduction potential. So we'll simply convert it in the oxidation potential. That will give you a positive value in 0.763. Now simply add it with Cd2 plus and Cd, and that will give you your E naught. So see, same thing is done. So we have calculated E naught first of all. So this minus this, that will give you 0.360. So first of all, we have also written the cup of say half reactions, and then we have done it for adding. Now delta G naught is equals to minus NFE naught. E naught we have calculated, and we already know it is 2. F is 96485, and that will give you delta G naught value as 69.5. Okay, so this is the delta G naught value. It is 69.5 kilojoule. Clear? Okay. Now, next what we will do? Next, we will see some more exercise. Okay, we will see some more exercise. So let's see some exercises first of all. So for this question, we have to calculate the equilibrium constant for reaction, and this is the reaction. E naught value is given. So how will calculate the equilibrium constant? Say, so we have to calculate the equilibrium constant for this reaction. E naught value is given. So how I will calculate it? So let's see. Okay. So we know that E naught is equals to 0.059 by 2 log Kc. We have seen that equilibrium, this equation turns into, your Arnast equation turns into this equation. Now we know that E naught cell is 0.46. We will put that value here, rearrange the terms, and we will get log Kc value as 15.6. Therefore, K is equals to 10 to the power 15.6, and therefore the answer is 3.92 into 10 to the power 15. Clear? Now next, the standard electrode potential for Daniell cell is 1.1 volt. We have to calculate the standard Gibbs free energy for the reaction. The standard electrode potential of Daniell cell is given. You have to calculate the Gibbs free energy. How will calculate it? So very easy. Delta G naught formula we know. Delta G naught is equal to minus NFE naught. If you see the value of N, it is 2. F, it is 96487. Just put all these values. You will get it as minus 21,227 joule per mole. Convert it to kilojoule per mole. That will give you a negative of 212.27 kilojoule per mole. Clear? Okay. Next question. Calculate the potential of hydrogen electrode in contact with a solution whose pH is 10. Okay, we have to calculate the potential of hydrogen electrode and H plus concentration is given. So what formula we'll use? We will simply use the Nernst equation. So we know that E cell is equals to E naught cell minus RT by NF ln H plus. Now RT by ln H plus, so we know that H plus concentration is given 10 to the power minus 10. Sorry, pH is given 10, therefore H plus concentration is 10 to the power minus 10. Put the values. Now very important thing. So we take E naught of hydrogen as the standard one. So this value will be 0. Okay. Therefore, your overall value will come out to be minus 0.0591. So we put these values, all of these values here, and it will give you 0.591. Next question. Next question says that we have to calculate the EMF of the cell in which the cell reaction is taking place. This is the cell reaction that is given. Again, we have to calculate the EMF, and concentrations are also given. So what you will do, you will use the Nernst equation. E naught cell here we will know. So E cell is equals to E naught cell minus RT by NF. Now we are taking here Ni2 plus by Ag plus square. Why we are taking square? Because see, this is the balanced equation and Ag plus is having 2 as the coefficient. Okay, so that is the reason we are taking square, and since 2 electrons are involved, so N is equals to 2. So that will give you this thing, and if you just calculate whole of this, then the value will come out to be 0.914. So this is the way, very simple to solve. So these are just some numerics that you can do. Okay, that will give you 0.914. Next question. So this is your, now we have to calculate, we have already calculated E cell. Now what we have to calculate? We have to calculate the EF of the cell. Next thing is delta G. Okay, we can also calculate the delta G naught from here. So minus 2 Fe. Next question. Okay, next question, what does it says? It says that the cell in which the following reaction occurs. Okay, cell in which the following reaction occurs. Okay, the value is given of E naught cell, that is 0.236 at 298 Kelvin, and this is your equation. We have to calculate the standard Gibbs free energy and the equilibrium constant. So first of all, standard Gibbs free energy is given by minus NFE naught. Okay, that will give you N is equals to 2 according to this equation. If you see here, then Fe3 plus is giving to Fe2 plus, but 2 Fe3 plus are there. So if you just calculate, you will get the value as 6. We are going to 4. Okay, from 6 we are going to 4. Right? Where 6 we are going to 4. So 2 electrons are involved. Okay, 2 electrons are involved. So delta G naught value is this. Okay, clear? So that is 45.54. Next, again we have to calculate the Kc. We already know that delta G naught is equals to minus RT and K, or 2.303 RT log Kc. Put these values here. that will give you log Kc is equals to 7.981. Therefore, Kc is equals to 9.57 into 10 to the power 7. Okay, so this was all for today's class. So with this, we have completed the thermodynamic aspect of your electrochemistry. Thank you.